We're working on Chapter 2, Input, Processing, and Output. We're going to start with how to design a program. There is a definite cycle that repeats when you're designing a program. Typically, it's going to go with, you're going to design or plan your program. So you're going to start with plan. And then you are going to write your code. Then you're going to look for syntax errors. We're going to come back to those two. And then you're going to test it, typically for logic errors. And then you're going to fix the logic errors. And then you will probably restart all over again as you add additional components, because on a large program, something like Microsoft Word, you're not going to write the entire program. You're going to write one function, like being able to bold a word or something like that. So planning in programming in this class, there's 3 different tools that we use for planning. We're going to use pseudocode, which is my favorite one to use, and it's like doing an outline for a paper. We'll also be working with flowcharts, which give you a good visual of how things are going to work. And once we get into object-oriented programming, we're going to use unified modeling language, and we'll come back to that later. Planning your code is usually the hardest part of the process. It's fairly straightforward at this level because we're going to tell you what you need. But if you were in the working environment, you would start by interviewing the people you were working with, job shadowing. You'd have to come up with the requirements yourself. One example, when I was working as a professional programmer, I had to do a custom billing program that was currently being handled by a secretary who was working with Microsoft Excel to do billing. I spent several days learning exactly how she did the job. I did it myself and had her check my work. Then I wrote the program and we compared them side by side until we were getting the same results before we put the program into implementation. So if you're a programmer in the real world, that's part of your systems analysis and design, where you're determining what's needed. In this class, we will give you basically what equates to a word problem, and you're going to have to take that word problem apart and turn it into the logic for the program. And you'll be using one of these 3 tools for almost every program that you do. Coding is done using an IDE, Integrated Development Environment. We have an excellent one that we're using in this class. We're using the PyCharm program for JetBrains, and that one actually will indicate syntax errors while you're programming. So in our programming code, we're going to be looking for a green check mark in the top right-hand corner of our screen because that indicates that there are no syntax errors. You don't want to wait to test your program at the end. When I was first learning to program, I was working in Java, and I wrote an entire program that took me more than 3 hours to debug. It told me that the compiler, which was in the DOS operating system, told me that I had 99 errors because that's the most it could show. I really only had 1. I was missing a semicolon about 10% of the way down the first page, and that caused every single line beneath it to have an error. It took me a really long time to find it. When you're testing things, you actually want to test, you're looking for syntax errors concurrently as you go along, and it will pop up, our compiler will pop up errors as you go, but you want to test pretty much with each logical paragraph of code. So each spot where you can logically test it, 5 to 10 lines of code, you want to run it, fix it, and then go through this cycle of code, fix the syntax, test, fix the logic errors. So a syntax error is like a grammar error. It's where you've spelled something wrong, missed punctuation, you have an error in how you're coding. A logic error, the code will run, but it gives you the wrong results.